I have a very small animation here, and you can go ahead and work with this file if you want, or you can create your own animation. What I wanted to do is do a very quick, kind of like boots in the snow print or boots in the snow effect, so that we're going to leave some boot prints in here, and show you how we might use a solver SOP to create this effect. So what we want to do is go into our grid object here, and we'll use a solver. Just plug that right in. So if we go into the solver, we have our previous time step, we've got our inputs, but we don't have that torus coming in. So to make sure it can interact, let's go ahead and bring in object merge here. And then let's go ahead and grab our torus object. Make sure that we transform that into this object. I'm going to go ahead, scroll forward a little bit, and let's go find a frame where we penetrate through here. So let's put down a group, and let's go find any points that are actually inside the torus that have penetrated through it. So let's go and just use a group create. Wire that right into the first input and our torus into the second. We will call this push me. There you can see push me, and that is going to be a point group. And we want to make sure that we are replacing every point that would already be part of this group. So every single frame, it's going to not add those points to the group, but just replace it. We'll turn off the base group, and we'll turn on bounding. And then we will change this to bounding object. So we can see that those points are now in here. So the next thing to do would be to displace based on the torus here. We're going to use an attribute VOP, and we'll just do it right here in VOPs. So the second input is going to be our torus. We'll go inside. And we have so many different ways of doing this. I'm going to show you one, but you can continue to devise your own strategies or ways of doing this and enhancing this effect. But this is just a pretty simple way of doing it. We're going to find out where the closest point on that torus is, and then we'll move the points there. So let's go and use XYZ distance. This will give us the closest point on the surface of the torus. All we need to do is plug the input into our second input. That would be the torus coming in. And then our position is that position here. Max distance we can leave at a high value there. So this gives us the distance to the closest point on the surface, the primitive number where that would be, and then the primitive UV where that is. But this doesn't actually give us the position. So we need to do a primitive attribute to retrieve that position from there. So we need to do the same file going into our output 2, or input 2 rather, and then we connect primitive to primitive, and then UV into UV, and then make sure that we are retrieving position. We can then set this to our position. Now if we go all the way back up, we have to reset our solver here. We have one other thing we didn't do, which is to make sure we are using just that push me group. So let's go back up. Now you can see that we're denting, but we got one problem, which is that these points are coming along for the ride once they've already penetrated. So we could move these points even further away, but whenever it scoops under, it's always going to be pushing the points up. That might not be something we want. It's kind of up to us how we deal with this, but the way I'm going to do it would be, we'll just take a look right here, is I'm just going to clip this torus so that we only have a valid position if it's on the same plane as our ground. So what we'll do is we'll just clip the torus here, and we will choose the negative Y direction and plug that in instead to our second input. Go ahead and rewind. And now that's working the way it should. So we do get this kind of bad stretching here, and that could be acceptable, but maybe what we'll want to do is just resample the mesh at this point so that we get something that's a little cleaner looking. So let's go back in here. What we'll do at the end of this displacement here is we will resample it, but first I want to make sure that we group just the points we want. So I'm going to use a group promote because the resample SOP needs primitive groups here. We're going to go from points to primitives, and the group is push me. Now we will resample. Oh, sorry, not resample, remesh. We will remesh just our push me group. And we can leave that as is. I'll just put a null down here. Let's make sure that we're calling this out. Let's take a quick look. So now we're getting this kind of footprints in the snow effect. And it's working pretty well. We could add some additional displacement if we want. We could do a bunch of things to make sure that there aren't any like very, very small penetrations and stuff like that. But for just a basic effect and kind of getting our feet wet with the solver SOP, this is a pretty good introduction.